morning, good afternoon, hello, how are you doing? Okay, we have numbers 1 through 9 on Cumulative Review 5. Wow, it's a very exciting time. Okay, number 1 said to restrict the domain of the function, of the original function, so that it has an inverse, and find its inverse in the domain of the inverse. Okay, remember, in order for a function to have an inverse, it must be 1 to 1. So, and what that means, it must pass the horizontal line test. So if I think about this function here, it's our squared function. It's going to look something like that. Now that's a terrible parabola. All right. However, we can see that it doesn't pass our horizontal line test because our function hits that horizontal line twice. Well, in order to restrict our domain, we want to look at one side of our function. Okay, so I'm going to look at the positive side here of our function. And in order to look at the positive side, I must think about the x value of my vertex here. Well, my vertex is 5, negative 2. And how did I get that? Because here I shift right 5, on the inside do the opposite, and down 2. Well, in order to restrict my domain, I look at my x values. All right, so I look to the right, so x must be greater than or equal to 5. Okay. Remember, to find the inverse of a function, I replace f of x with y. Alright, and then I replace x and y. And now we're going to solve for y. So I'm going to add to the other side. Then I'm going to take the square root of both sides, so undo that squared. So now I have the square root of x plus 2 equals y minus 5. Lastly, I'm going to add 5 to both sides. So f inverse of x is the square root of x plus 2 plus 5. Now I also have to restrict my inverse, the domain of my inverse. Okay. So in order to do that, all right, I want to think about my starting point as well, how this shifts. Well, this shifts, if it's on the inside, we do the opposite. It shifts 2 units to the left. All right, and up 5. So I want my x values to be greater than or equal to negative 2, since my function shifts 2 units to the left. Number 2, find the domain and zeros of each function below. Please write your domain in interval notation and your zeros as coordinates. Okay, so finding the domain. All right, we know that we cannot take the square root of a negative number. So I'm going to say that that whatever is underneath my square root must be greater than or equal to 0. Okay, now I want to solve for x. Greater than or equal to 0 means it must be positive. All right, solve for x. Add 2x to the other side. 5 is greater than or equal to 2x. Divide by 2. 5 over 2 is greater than or equal to x, or x is less than or equal to 5 over 2. Okay, that means the highest possible value for x is 5 halves. So that means I'm going to start at negative infinity and go to 5 over 2 and include that value. All right. To find the zeros of my function, I'm going to set my function equal to 0 and solve. Well, to get rid of the square root, I square both sides. 0 squared is 0. 5x minus 2. I'm going to add 2x to the other side. 2x equals 5. Divide by 2, x equals 5 over 2. To write that 0 as an ordered pair, y is equal to 0, so it'll be 5 over 2, comma 0. Alright? Now, this is the only time with square roots will be the only time that this happens, or these match. Okay, so don't get the habit of writing the zeros in the domain as the same number in letter B. All right, a lot of us have made that mistake in the past. Don't be that person. How about it? Okay, let's find the domain in letter B. To find my domain, I know the denominator of my function cannot be equal to 0. So I said 25x squared minus 9 cannot equal 0. Now you can do this two ways. All right, I can factor this or I can solve by using a square root. All right, I'm going to choose to factor this because I like factoring. I know this is the difference of two perfect squares. I have a 25 and a 9. So it's 5x plus 3. 5x minus 3 equals 0. Set each factor equal to 0. 5x plus 3 equals 0. 5x minus 3 equals 0. Okay? Solve for x. X equals, or cannot equal, negative 3 over 5. X cannot equal positive 3 over 5. So our domain, and because it's so long, I'm going to write it down below. Our domain is negative infinity to negative 3 over 5. Don't include negative 3 over 5. Negative 3 over 5 to positive 3 over 5. Don't include that. Union 3 over 5 to infinity. Okay. Next, I want to find my zeros. All right, to find the zeros of the function, I'm going to set my numerator equal to 0 and solve. So 2x plus 7 equals 0. Subtract the 7. 2x equals negative 7. Divide by 2. X equals negative 7 over 2. So it's negative 7 over 2 comma 0. All right. Let's try number 3. Let it be with number 3. How about it? Write the linear function. Okay, remember a linear function is either in point slope form or slope intercept form, which means I have to find my slope first. All right, this, if my input is negative 3, that means my x is negative 3 and my y is 7. My x is negative 5 and my y is negative 15. Find the slope. Negative 15 minus 7 over negative 5 minus negative 3. Add. I got negative 22 over negative 2, which gives me 11. I can write this in point slope form. All right, where it's y. Remember, point slope form is this. Where this x and this y do not change, only y1 and x1. So I can write this as y minus 7 equals 11 times x plus 3. Or I can write it as y plus 15 equals 11 times x plus 5. Or if you're a slope-intercept person, that's y equals 11x plus 40. All three of these answers are acceptable. All three. Isn't that neat? That's pretty neat. Okay. Number 4, solve for x. All right, that means I want to get every term with an x in it on the one side of my equal sign. So I'm going to do two things in one. I'm going to subtract ax from both sides, and I'm going to subtract 5b from both sides. Okay, because every term without an x should be on the opposite side. So I have 3x minus ax equals negative m minus 5b. Here I see I have a greatest common factor of x, so I take that x out. 3 minus a equals negative m minus 5b. I want to isolate my x. I want x by itself. There's multiplication. So I divide both sides by 3 minus a by 3 minus a. This one is commonly missed. Let's make sure you understand what we're doing here. These two cancel out. So x equals negative m minus 5b over 3 minus a. Biggest thing with this one, get all of my terms with x on one side of my equal sign, all my terms without x on the other side of the equal sign. Okay. This looks like it's probably going to be the last problem, maybe, of this video. So we're going to bear with me. Here we go. I got my original points, which I get from my major terms. There are 4 points. There. So I get, holy buckets, let's see. I get -2, -2. -1, 2. 1, -1. And 2, 3. Okay? Applying the transformation means I need to work from the inside out. Well, the first thing on the inside is this -1. What do I do if it's a -1? I do the opposite, and I move it to the right 1 unit. I'm moving to the right 1 unit that is only going to affect my x values. I'm moving to the right 1, okay, this becomes -1, -2. Right 1, this becomes 0, +2. So really I'm adding 1 to all my x values. This becomes 2, -1, and this becomes 3, 3. Okay. Next, I want to apply, I took care of the inside, outside, so I'm going to apply this 1/2. So it's a vertical shrink, spelling, by 1/2. If it's on the outside, that means I'm going to multiply all of my y's by 1/2. Okay? So, -1, comma, -1. 2 times 1/2, 0, comma, 1. -1 times 1/2 is 2, comma, -1/2. 3 times 1/2 is 3, comma, 1.5, or 3/2. Next thing, apply the negative. That means I'm going to reflect over x. Okay, so that means that's only going to affect my y values. My x values do not change. I'm going to change my y values, meaning I'm going to, if they're positive, I'm going to make them negative. If they're negative, I'm going to make them positive. So -1, 1, 0, -1, 2, comma, 1/2, and 3, comma, -1.5. Last thing, I'll take this -3, which means I'm going to go, since it's on the outside, I'm going to go down 3, which means I'm going to subtract 3 from every single y value. -1, -2, 0, -4, 2, comma, -2.5, and 3, comma, -4.5. Alright, there's our transformation. These are our last points. After you're done, you should graph those points, because why not? Graphing is fun. So I got -1, -2, 0, -4, which is kind of down here. 2, -2.5, and 3, -4.5. So it should look something like that. Alright, that's it. I'm going to make another video for 6 through 9. There you go.